The most terrifying distances in space your brain can't understand. I want to start with something absurdly small. A meter. Just 1 meter. The length of a long stride. An arm and a bit more. You understand a meter. You don't have to think about it. Your arms understand it. Your legs understand it. A meter is baked into the hardware of your body. And that's the problem I want to talk about today, because everything your brain knows about distance, everything evolution spent 4 billion years teaching you, tops out at maybe 100 kilometers, the distance you can see from a mountaintop on a clear day. That's it. That's the entire measuring stick you were issued at birth. And today I'm going to take that measuring stick and break it slowly, piece by piece, until you understand something that I think is genuinely more frightening than any monster anyone has ever put in a movie. Not because space is big. You've heard that. Space is big. It's a cliche. It doesn't scare anybody. No. What I want to show you is that the distances in our universe aren't just large. They are structurally hostile to connection. The geometry of the cosmos is arranged not by anyone, but by the laws themselves, so that intelligence is quarantined, isolated, sealed inside a bubble it can never leave. And by the end of this video, I want you to understand why, when somebody asks me whether we're alone in the universe, I say it doesn't matter whether we are. The laws of physics have already made sure we might as well be. Now look, let's start small and let's be very precise here, because precision is where the horror lives. Light travels at just under 300,000 kilometers every second. In 1 second, snap your fingers, light goes around the Earth's equator 7.5 times. Already your intuition has left the building. Nothing in your evolutionary history moves like that. But fine, we can write the number down. And writing numbers down is what physicists do when their intuition fails. So let's keep going. The moon, 1.25 seconds away at light speed. When the Apollo astronauts talked to Houston, there was a pause in the conversation, a little awkward gap. And that gap was the distance. You could hear geometry. The sun, 8 minutes and 20 seconds, which means, and I want you to actually sit with this, if the sun vanished right now, ceased to exist, you would not know. You would go on sipping your coffee in sunlight for 8 full minutes, warmed by a star that is no longer there. Not because the news travels slowly, because in a very deep sense, the event hasn't happened yet at your location. The speed of light isn't a speed limit on rockets. It's the speed of causality itself, the maximum rate at which one part of the universe is permitted to matter to another part. Hold on to that phrase. The rate at which things are permitted to matter. We're going to need it. Now let's leave the solar system, and here's where I have to be honest with you. I can't help you anymore. Nobody can. The numbers from here on out are not comprehensible. They are only writable. Voyager 1, the fastest thing our species has ever thrown into the dark, launched in 1977, moving at 17 kilometers every second for going on 50 years. Voyager has traveled about 23 light hours. The nearest star, Proxima Centauri, is 4.25 light years away. If Voyager were aimed at it, which it isn't, it would arrive in roughly 75,000 years. 75,000 years ago, human beings had not yet painted the caves at Lascaux. That's the nearest star, the very nearest one. Our galaxy contains a few 100 billion more of them, spread across a disk 100,000 light years wide. And our galaxy is one of maybe 2 trillion galaxies in the observable universe, which spans about 93 billion light years from edge to edge. I can say these words, you can hear these words, and I promise you, nothing is happening in either of our brains that corresponds to their meaning. We are apes reciting incantations. But, and this is the turn, so pay attention, the size is not the terrifying part. I know every space video tells you the size is the terrifying part. It isn't. Size is just a number, and numbers are harmless. The terrifying part is what the size does when you combine it with that finite speed of causality. So let's follow the logic all the way down. Picture something in your head, a map, but not of space, a map of possibility. Time runs upward, space runs sideways, and you are a single point on it, right here, right now. From that point, everything you can ever influence spreads upward and outward in a cone. Physicists call it your future light cone, the region of the universe where your existence is allowed to matter. And everything that could ever have influenced you spreads downward and outward in another cone. Put those two cones together and you get a diamond. Physicists call it your causal diamond. And here is the point. And the point is actually quite subtle. That diamond is the whole of your reality, not poetically, operationally. Anything outside your causal diamond cannot send you a photon, a particle, a gravitational ripple, a signal of any kind, and you cannot send one back. No experiment you could ever perform, even in principle, even with infinite technology and infinite time, could detect it. Now, in physics, we have a rather brutal standard. If something cannot be measured, cannot interact, cannot leave any trace on any observation ever, in what sense does it exist? I'm not being mystical here. I'm being an accountant. The ledger must balance. And when you run the accounting, you find that the overwhelming majority of the universe, almost all of those 2 trillion galaxies, lies permanently outside our diamond. They are not far away. Far away implies you could, in principle, close the distance. They are causally disconnected. If there is a civilization out there right now, in one of those galaxies, brilliant beings looking up at their own sky, asking their own version of, "Are we alone?" They are ghosts to us, and we are ghosts to them. Their path through space-time and ours never intersect, never touched, never will. Two soap bubbles that will not merge before the universe ends. And even inside the diamond, even for the neighbors we could technically reach, consider what a conversation actually costs. Suppose generously there's a civilization 500 light years away, practically next door on cosmic scales, close enough that we share a galaxy, a neighborhood, a sky. We send a message, "Hello, anyone there?" That message arrives in the year 2526. They deliberate, let's say they're quick, let's say they answer immediately, and their reply reaches Earth around the year 3026. One exchange, one hello and one hello back, and a full millennium has passed. That's longer than the gap between us and the Norman conquest. Entire languages are born and die in less time. Who receives that reply? Not the people who sent the question, not their children, not their civilization, possibly not their species in any form they'd recognize. A conversation, in any meaningful sense, question, answer, follow-up, understanding, requires that both parties persist, coherent, and interested across timescales that no human institution has ever survived. The pharaohs are 4,000 years gone, and we can barely read their mail. So even where causality permits contact, time devours it. The universe doesn't just separate minds in space, it staggers them in time so that even neighbors are effectively taking turns existing. It's a bit of a nuisance for our sci-fi fantasies, but it gets worse. Oh, it gets so much worse. Because so far I've been describing a static universe, and ours is not static. Ours is running away from itself. In 1998, two teams of astronomers measuring distant supernovae found something nobody wanted to find. The expansion of the universe is accelerating. Empty space itself carries a tiny, tiny energy. We call it the cosmological constant, dark energy, lambda, pick your favorite name for the thing we don't understand. And that energy pushes space apart. And the more space there is, the more pushing there is. Now, don't get confused by the popular science version of this. Nothing is flying through space faster than light. The space between things is stretching, and there's no speed limit on that. Because stretching space isn't a signal, it isn't causality, it's just geometry doing what geometry does. But the consequence is a knife. Because if the space between us and a distant galaxy is growing faster than light can cross it, then light launched from that galaxy today is like a swimmer on a treadmill of water swimming toward us forever at full speed and losing ground every second. That galaxy has crossed what we call the cosmic event horizon, which currently sits about 16 billion light years out. And here is the sentence I want you to remember from this entire video. Galaxies are crossing that horizon right now. As you watch this video, entire galaxies, hundreds of billions of stars each star with its planets, each planet with whatever stories it holds, are slipping over the edge of our reality. Not being destroyed, worse than destroyed, being edited out of everything we can ever in principle know or touch. Their last photons will crawl toward us for eons, stretched redder and redder and fainter, like a voice getting quieter on a phone call that never technically ends. And then, nothing. The universe is not merely too big to explore. The universe is actively deleting itself from our future. Run the clock forward, and here I'll admit the timescale is absurd, but the physics is solid. 100 billion years or so, and everything outside our little local group of gravitationally bound galaxies will be gone from the sky. Astronomers born in that era, if any exist, will look up with perfect instruments and see one merged galaxy floating in absolute blackness, and they will conclude, from flawless observations and impeccable logic, that the universe consists of one island of stars and nothing else. They will be wrong, and they will have no possible way of discovering it. Their science will be honest, careful, and false. And now let me turn that around and make you properly uncomfortable. What has already crossed our horizon? What did the universe delete before we ever opened our eyes? We assume we're looking at the whole show. The kid in the 100 billion year future assumed that too. Now, let's be precise about what this means for the question everybody actually cares about: company, other minds. Because you'll hear the Drake equation trotted out. Billions of stars, billions of planets, surely somebody's home. Fine, maybe somebody is. But notice the equation counts existence, and I've just spent 20 minutes showing you that existence isn't the currency that matters. Contact is the currency, the exchange of information, and information is exactly the thing the geometry rations. And it gets even more depressing when you consider the thermodynamic balance sheet, because what is an intelligent observer, physically? It's a pocket of astonishingly low entropy, an island of order, and the second law of thermodynamics says you don't get order for free. Every thought you have is paid for by dumping disorder into your surroundings. Your brain is a furnace that burns structure to make ideas. Scale that up to produce one biosphere, one lineage of thinking creatures. The universe had to spend a star, a giant entropy pump, pouring low-entropy sunlight onto a planet for billions of uninterrupted years, plus earlier generations of stars that died to forge the carbon and oxygen and iron in your blood, plus a galactic neighborhood calm enough not to sterilize the whole project with a nearby supernova. Intelligence is not cheap. Intelligence is the single most extravagant purchase the cosmos makes, and the price is paid in oceans of wasted space and squandered energy. Vast emptiness isn't the backdrop to life. Vast emptiness is the receipt. And consider the invoice on our own planet, because it's sobering. 4 billion years of continuous solar payment, and for roughly 3 billion of those years, the most sophisticated thing on Earth was slime, single cells, pumping entropy, going nowhere in particular. Brains that could do arithmetic showed up in the last 100th of 1% of the project. radio telescopes in the last 1 millionth of it. If the entire history of life on Earth were compressed into a single year, the window during which this planet could send or receive an interstellar signal would be the final 2 seconds before midnight on December 31st. Now imagine two such planets, each flickering awake for its own 2 seconds, somewhere in the same galaxy. What are the odds their 2 seconds overlap? That's the real lottery, not whether life arises, whether two flames happen to be lit at the same cosmic instant, close enough to see each other before one or both gutter out. So when you ask why observers should be sparse, spread thin, one per unimaginable volume, thermodynamics answers with a shrug, because that's what they cost. And there's an even stranger ceiling above all this, which I'll only wave at. We've learned that the amount of information you can pack into any region of space is finite, proportional, bizarrely, to the region's surface area, not its volume. Cram in too much, and the whole thing collapses into a black hole. The universe has a maximum density of knowing. Even in principle, you cannot fill space wall to wall with minds. Sparseness isn't bad luck. Sparseness is written into the architecture. So put it all together, all of it, and consider what the laws of physics have built. A speed limit on mattering, a horizon that eats galaxies, a thermodynamic price tag that makes minds rare, a hard ceiling on how densely thought can be packed. Every one of these, independently, pushes in the same direction, toward isolation. If you were designing a universe to keep intelligent observers apart, to make sure each little flame of consciousness burns alone in its own sealed room, I honestly don't know what you would do differently. I'm not saying it was designed. Nature doesn't need intentions to be cruel or to look like it has them. I'm saying that loneliness here is not an accident of where we happen to live. Loneliness is a feature of the geometry. And now the part where I'm supposed to comfort you. And I won't, quite. But I'll offer you something better than comfort, which is a change of perspective. Because you can hear everything I've said tonight as a tragedy, and most people do. Or you can hear it the way I've come to hear it, after 40 years of turning these equations over in my head. Within our causal diamond, within the only region of the universe that can ever be real for us, we may well be it, the observers. The only place in this entire bubble of space-time where the universe has folded matter into a shape that can look back at itself and ask what it is. Every equation ever written down, every measurement of a distant supernova, every child pointing at the moon, that's not humanity doing science. That's this region of the cosmos becoming aware of itself through us, because there is no one else here to do the job. The stars can't know they're stars. The horizon can't know it's a horizon. We are the knowing, and our own horizon is closing slowly, on timescales that dwarf everything, but closing. The sky is emptying. The deletions continue. And someday the window through which anything can be learned will shut for good. Which means the terrifying distances I've described aren't just a prison, they're a deadline. Whatever understanding gets wrung out of this universe, whatever beauty gets witnessed, whatever it all meant, that gets decided inside the diamond by whoever is inside it while the light still arrives. That's us. Maybe only us, not the audience of the cosmos, the last or perhaps the only witness it will ever get in this corner of everything. So no, your brain can't understand these distances. It was never meant to. It was built to judge the leap between two branches. But it can do the one thing the distances can't forbid. It can understand that it can't understand, write the number down anyway, and keep the flame lit a little longer inside the only bubble of reality we will ever have. The window is still open, the light is still arriving, and the horizon is patient. Let's get to work.